Hi guys, Mrs. H here. So we're going to go ahead and take a look at valence electrons and then Lewis dot diagrams. So remember our electrons and periods. So remember the atomic number is found on, it's the small number right here. And so because atoms are neutral, the number of protons and electrons are equal. And so this number right here, 42, will also tell us the number of electrons. Now, valence electrons are the number of electrons in the outer energy level of an atom. So remember we learned earlier that if we count our groups across our periodic table, skipping the transitional metals, that this will tell us how many valence electrons there are. So now let's go ahead and put the Bohr model with this so we can actually see what we're talking about. So here I have a Bohr model of oxygen, and we know oxygen has 6 electrons, where we place 2 of those electrons in the first energy level, and then 1, 2, 3, 4, 5, 6 electrons in the outer energy level. So that makes 6 valence electrons. Now, if I look at neon, neon has 10 electrons, 2 in the first, and 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in the outer energy level, so therefore neon has 8 valence electrons. So when we're looking at our Bohr models and we look at that outer energy level, the number of dots or the number of electrons in that energy level will tell us our valence electrons. And so if we notice, if we go across our periodic table, I have hydrogen. So hydrogen is in group 1, is in the first row, and so it has 1 valence electron. If I look at helium, it's all the way at the end, and so helium has a full energy level. It's the last one in that column, so it has to be full, and it's full with 1, 2 electrons, or 2 valence electrons. As we continue to go through our periodic table, we're going to see some trends emerge. So notice hydrogen was here and helium was down here. First row, our first column, 1 energy level. Last column, full energy level. So let's see what happens here. So notice in our period 2, so period 2 has 2 energy levels. So lithium and beryllium both have 2 energy levels. Why? Because they're both in period 2. But if we notice, lithium is in group 1 or in the first column, so it only has 1 electron in the outer energy level. So I have 1, 2, 3 electrons for lithium, but 1 in the outer energy level, or 1 valence electron. So what happens with beryllium? Beryllium again has 4 electrons. So notice what happens. I put 1, 2 in the first, 1, 2 in the second. So beryllium has 2 valence electrons. And where is beryllium located on the periodic table? Well, they're in the second column. So second column, 2 valence electrons. 1 column, 1 valence electron. And so we'll see this pattern as we move through the periodic table, skipping our transitional metals. So if I'm in the first column right here, I have 1 valence electron. Here I have 2. We skip those transitional metals. This becomes 3, 4, 5, 6, 7, and this we say full, because remember, helium only has 2 and the rest of them have 8. And so that's what we see here. So here's examples of other elements in period 2. Notice what happens. They all have 2 energy levels, but what's different? The number of valence electrons. So notice oxygen has a total, or not oxygen, sorry, this is not oxygen, this is boron. Notice boron has 3 valence electrons because they're in that third column. And then oxygen, notice, is 6 because, again, if we continue to count across our periodic table, we'll be able to determine the valence electrons that will be in this Bohr model without even having to construct the Bohr model. And so again, here we go again. Here's the third period. The third period, the same thing's going to happen. So notice I have here, this is sodium. So sodium has full first energy level, a full second energy level. So now we have third energy level, but notice how many electrons? 1 electron. And where is sodium in the periodic table? It's on the first column, okay? And so as we move through, again, we're gonna see that pattern emerge for our columns, okay? So our groups tell us the number of valence electrons. And so now we can see why this happens. Before we just needed to know them, but now we know why. Okay, so now I have Lewis dot diagrams. So we're going to use valence electrons and our knowledge of valence electrons to construct our Lewis dot diagram. So here we have some examples of what a Lewis dot diagram is, but what is it really telling us and what is it showing us? It's a diagram of the valence electrons in an atom, and it will come in handy when we're looking at ions and we're looking at bonding in atoms in our future units. So again, here's our rules. We're going to determine the number of valence electrons by looking at the group the element's in. We're going to write the symbol. We're going to place dots around the symbol to represent the valence electrons, starting counterclockwise and go around. We're only going to place 1 electron on each side until it's full. So let's go ahead and look at carbon. So carbon is in the 14th group. But remember, we need to ignore the transitional metals. So that means carbon has 4 valence electrons. So notice we write the symbol is C, and then I place 1, 2, 3, 4 dots around each side to represent the 4 valence electrons. Okay, so remember we did the fluorine model of a Bohr model, so let's use this to now make a Lewis dot diagram. So remember, looking back, we have 1, 2, 3, 4, 5, 6, 7 valence electrons. So what do we need to do? I need to write my symbol F and then place 1, 2, 3, 4, 5, 6, 7 dots around. And so you can see how the Bohr model and the Lewis dot are related, and we can use them to gain information about fluorine. So if you have any questions about constructing Lewis dot diagrams, make sure you're reaching out to me, because remember, I'm always here to help. Bye.